All right, polynomial functions, Unit 11, Day 1. So a polynomial, sorry, I'm struggling. A polynomial function is in the form of an to the xn power, blah, 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 blah. Okay, where an is called the leading coefficient. So the number in front of the exponent with the highest power is the leading coefficient. I'll write that down. So the number in front of the exponent with the highest power, sorry, I can't spell, power is the leading coefficient. Okay, that's basically what that's saying there. So we have different types of polynomials, and we give them names based on their degree. Okay, so if we just have some number, that's a 0-degree polynomial because there's no x there, there's no exponent on any x. The only exponent would be 0, and that's a constant function, so that's called constant. If we have negative 5x plus 1, x is the highest variable power we have there, and the power is 1, and that's a linear function, or linear polynomial. Next one's 2, because that's the highest, and that's a quadratic. Then 3, and that's a cubic. 4 is a quartic, and 5 is a quintic. Okay, now for the leading coefficients, on that first one, it's 4. That's the only number, that's the only thing it could be. Okay, on the second one, we have to look at the number in front of the x, so it's negative 5. That third one, look at the number in front of x squared, that's 12. Fourth one, look at the number in front of x cubed, that's negative 1. Fourth, look at the number in front of x to the fourth, it's negative 3. Then fifth, look at the number in front of x to the fifth, that's 9. Okay, now let's get into what some of these graphs look like. So if it's constant, that's f of x equals c, where c is just a number, and that's just a line. It's just a horizontal line at whatever the number is. So if the number is 2, it'd be a horizontal line at y equals 2. If the number is negative 4, it'd be a horizontal line at y equals negative 4. Okay, for linear, that's f of x equals x. You guys should know this one. That's just the diagonal line. Quadratic, f of x equals x squared, and that's just the U-shaped graph. Cubic, f of x equals x cubed, starts low, ends high. Okay, now quartic, f of x equals x to the fourth, and that's still just a U-shaped graph. There is possibility for this to go more like up, but it could also just be the U, okay? Same thing with the quintic, so f of x equals x to the fifth. That's very similar to the cubic, but there could be more bumps in here. Just, we don't know, okay? It just depends. On the parent function, though, it just looks just like that. Now, we're going to use your calculator to determine end behavior. If you have your calculator, you can practice putting these in there. If not, I did put the graph on here so you can see. So we have f of x equals 4x to the fourth plus 6x cubed minus 4. That's what that graph looks like. Now, as x goes to negative infinity, f of x goes to positive infinity. And as x goes to positive infinity, f of x also goes to positive infinity. And I want you to notice here the sign of the leading coefficient and whether or not the exponent is even or odd. And see if you can notice some patterns, okay? So this was a positive leading coefficient, and the leading, it was a fourth power, so that's an even power, and they both went to positive infinity. Is that just a coincidence or not? I want you guys to try and figure that out as we continue to go through this. So now we have negative x squared plus x. That graph looks like that. Now as x goes to negative infinity, f of x goes to negative infinity. And as x goes to positive infinity, f of x goes to negative infinity also. Okay, notice some patterns here. Now 2x cubed, that graph looks like that. As x goes to negative infinity, f of x goes to negative infinity. As x goes to positive infinity, f of x goes to positive infinity. Okay, f of x equals negative x cubed, that's that graph. So as x goes to negative infinity, f of x goes to positive infinity. And as x goes to positive infinity, f of x goes to negative infinity. Okay, see if you're noticing patterns at all. Now, f of x equals negative 2x squared plus 4x minus 7. That's what that graph looks like. So as x goes to negative infinity, f of x goes to negative infinity. As x goes to infinity, f of x also goes to negative infinity. Now, f of x equals 1/2 x cubed plus 7. That's that graph right there. As x goes to negative infinity, f of x goes to negative infinity. And as x goes to infinity, f of x goes to infinity. Okay, if you notice, on all the even powers, both the end behaviors are the same. And if the leading coefficient was positive, they're both positive infinity. If the leading coefficient was negative, they're both negative infinity. Now, on the odd powers, they are opposite. They're not the same. But if it's a positive odd power, as f of x goes to negative infinity, f of x also goes to negative infinity, and infinity goes to infinity. So it just stays the exact same. But if it's a negative leading coefficient, it's switched. So negative infinity goes to positive infinity, and infinity goes to negative infinity. Okay? We're going to use that knowledge to fill out this chart. So if it's a positive leading coefficient and it's even degree, you're going to have some graph that both ends are going up. So as x goes to negative infinity, f of x goes to positive infinity. As x goes to infinity, f of x goes to infinity. So they're both positive. So if it's even degree and a positive leading coefficient, they're both positive. Now, if it's an even degree and a negative leading coefficient, they're both going to go to negative infinity. So as x goes to negative infinity, f of x goes to negative infinity. As x goes to infinity, f of x goes to negative infinity. They are both negative. Now for odd degrees, it's going to be a graph that looks like that. The left side, so if it's a positive leading coefficient, the left side's going down, the right side's going up. So you start negative and positive. So that means the left side's going to negative infinity, the right side's going to positive infinity. And it's just switched for the negative leading coefficient. For those, you start positive and negative. So for odd degrees, you can think, if it's a positive leading coefficient, I have to end positive. If it's a negative leading coefficient, I have to end negative, and then the other side is just the opposite. Okay? So we need to determine the sign of the leading coefficient and whether the function is even or odd. So for this first one, they're both going down, which means they're both negative. And since they're both going down, it's going to be even, and it's negative. Okay? For this next one, you start negative, end positive. We're ending positive, which means it must be odd, and it must be positive. Okay? Now, turning points. The points at which the polynomial function switches direction. If the turning point is higher than any nearby point, it's called a relative maximum. If it's lower, it's called a relative minimum. And these points, so the maximum and minimum values, are called extrema, or I'm really not sure how to pronounce that word. Okay, then turning points define where the function is increasing or decreasing. If you have your calculator, if you have the TI-84 or whatever, I want you to put this in there with me. If not, we will go over it in class. I just want you to practice doing it with me. So we want to find the turning points for x cubed minus 6x squared plus 7x plus 2. So I want you to graph this function. Click y equals and put it in there, and you will get a graph that looks like that. Okay? We're going to use the calc menu to find the minimum and maximum values. There's the maximum. That's a relative maximum. So to do this, you're going to go second trace in your calculator, go down to maximum. So go down to number 4. Okay? Move your cursor to the left side of that hump. So it's going to be like right here. You'll have like a little X guy right there, spider guy. Push enter, move it over, put it about right there. Push enter again, push enter one more time, and it will give you that point right there. Bah, I'm ahead of myself. So that's going to be 0.7, 4.3. Okay, that's that relative maximum. Now for that relative minimum, we're going to do the same. You go second trace, but this time instead of doing maximum, click minimum. So you're going to go down to minimum, and you're going to go to the left. So you're going to put your cursor right here. Then you're going to go to the right, put your cursor there, push enter, put your cursor there, push enter one more time to get that relative minimum, 3.3, negative 4.3. Now, for the increasing and decreasing intervals, think about you're just this little guy right here walking along this slope. Whenever you're walking uphill, because we're walking left to right, that's increasing. So this part right there is increasing, and this part right there is increasing. Okay? But in the middle here, I'm going to be walking downhill, so this is going to be decreasing. So whenever you're walking up, you're increasing, but when you're walking down, you're decreasing. You can think of like altitude. If you're walking up, you're increasing in how far away you are from sea level. If you're walking back down, you're getting closer to sea level. Okay? And these are always x values. You always use your x values for increasing and decreasing intervals. So the increasing interval, that's going to be from negative infinity to 0.7, because that's that x value right there. Then you have to put this little u in between because it's a union, and then 3.3 to infinity. The decreasing interval is from 0.7 to 3.3. Okay? Now let's use all of this to graph this function. So we have negative x cubed plus 3x squared. The first thing I want you to do is put it into your calculator. Okay, you're going to put it into your calculator and you're going to find the relative maximum, you're going to find the relative minimum. The relative maximum here, or relative minimum, let's do left to right, is 0, 0. And you can do that in your calculator, do second trace, go down to minimum, find that. Then do the maximum, is 2, 4. Now my increasing intervals, why am I doing this in a weird order? Okay, ignore the increasing and decreasing for now. So then we're going to graph our relative minimum at 0, 0, our relative maximum at 2, 4, and then we can just draw a basic shape of this graph. I know that the calculator gives you the graph, but I want to just make sure that you are putting it onto the paper also. Okay, now we can do our increasing and decreasing intervals. So it's increasing from 0 to 2, then it's decreasing from negative infinity to 0, and then 2 to infinity. Okay? And behavior, as x goes to positive infinity, f of x goes to negative infinity. And as x goes to negative infinity, f of x goes to positive infinity. My domain is your x value, so negative infinity to positive infinity. Range is your y values, which is also negative infinity to positive infinity. Okay? Really not that hard. The calculator does most of this for you, okay? You need to make sure you know how to find the relative max and relative min in your calculator. Let's do this one. So x to the 4th plus x cubed minus 4x squared plus 5. Put it in your calculator, you get that graph right there. This time we have two relative minimums. So my first relative minimum is negative 1.8 and negative 3.3. Put it in your calculator, do second trace, go down to minimum, left bound, right bound, enter one more time, it'll give you that. Then let's find that maximum, that's at 0, 5. And then the other minimum is at 1.13. You can do the increasing and decreasing right now if you want to. I want to draw this graph first. So if we go to negative 1.8, negative 3.3, there's that point. 0, 5, there's that point. 1.13, there's that point. And then we can draw that graph. Now this is increasing in the middle and then the right end. So it's increasing from negative 1.8 to 0 and then 1.1 to infinity. And remember, these are always x values. It's decreasing from negative infinity to negative 1.8 and then 0 to 1.1. And behavior, as x goes to infinity, f of x goes to infinity. As x goes to negative infinity, f of x also goes to infinity. Domain is negative infinity to positive infinity. Range is the bottom to the top. The lowest y value this hits is negative 3.3. So that's going to be negative 3.3 to infinity. Okay, take the quiz. I'll see you guys tomorrow.